All right, so my name is Ksenia Dmitrieva, and we are talking about content security policy today, and specifically about how we can fix cross-site scripting, avoid cross-site scripting, protect from cross-site scripting using content security policy. Can you guys, yep, just closer, whatever. Sure. I know there was another talk about content security policy today, and they were talking mostly about securing content and not talking about cross-site scripting. So a couple words. So I'm an associate principal consultant at Cigital. I was working with security for over 5 years. Before that, I was a developer, and in my free time, I do ballroom dancing. I actually came straight from ballroom practice as have a competition in a couple of weeks. So this is what we are going to talk about today. What is content security policy? Just kind of refresher. Why do we need it? Why did we come up with it? How does it help to fix cross-site scripting? And we'll talk about the details of version 1 and version 2 of CSP, why version 1 wasn't adopted as quickly as we expected, and what we're changing in version 2 to hopefully have it adopted. So first, we'll talk about cross-site scripting. Anybody familiar what it is? Yay, all right. So cross-site scripting in general is a vulnerability in the web application, in the front end, in the way you are interpreting the input that you received from the client, from the user, and reflecting that input, usually displaying on the page at some point without validating the input, without making sure this is what you expect. And so the input may contain JavaScript. Usually, when we talk about web, it's JavaScript. It could be like VB script or some other script that's running in the browser. So the script is injected into the page. Then the browser executes it, and it's just like any other injection, right? Just like command injection, just like SQL injection. The browser doesn't know that this data is supposed to be just data. It sees the word script, it sees the other JavaScript keywords, and runs it, right? And because the script came from somewhere who we don't trust, it could have been part of the URL, it could have been stored in the database. The script may contain malicious actions. And because it is being run inside the inside the client's browser, the person who is logged into the website, so the script has access to all the data that this person has on that website, their account numbers, their personal pictures, data, application forms, I don't know. So there are 3 different types of cross-site scripting. The first one is reflected. This happens when the payload is usually part of the URL, goes to the server, and then it is reflected immediately in the response. So it's executed immediately, it's in the response, it's run by the browser, the script is executed. Another type is stored, when the payload is not reflected immediately. It is stored somewhere on the server database file, any persistence layer, and it will be retrieved at some point. Even the attacker who's storing that, saving that in the database, doesn't know when exactly it's going to be retrieved. They just kind of store some stuff and hope that somebody will view this page and the script will get executed. So for example, it could be a blog post, right? You're writing the blog post doesn't have any filtration, you inject JavaScript and leave it there. And when this blog post is viewed by somebody, and this somebody is logged into the platform, then you can steal this person's information, right? For example, their login credentials, their session for that blogging platform. However, a few years ago, it's been a while, like 5 years ago, with all the new technology, with all the new website, client-side frameworks, a lot of JavaScript that is processing the data on the client side, we now have a new type of cross-site scripting that is called DOM-based, right? The DOM is the document object model. That's the representation of the HTML page in the browser. So in this case, that malicious script is executed completely on the client side. Now, the first two, we have something going to the server stores it, checks it, manipulates somehow, and then shows in the response. In the DOM-based case, all the manipulation is happening in the browser. And that's because the way the JavaScript is written, right? It's not, developer has to make a mistake first, right? Has to leave that vulnerability open because the JavaScript, for example, grabs some part of the URL, does some manipulations with it, and then shows in the page, right? And especially with all the single-page applications where everything is done in the browser, that's becoming more and more common. So how do we traditionally fix cross-site scripting? Well, we always say input validation and output encoding, the two main, main protections from any type of injection. So input validation, we know what input we are expecting. If that's a phone number, if that's an address, if that's an email, we check, we validate the structure, and we say, yep, it's a phone number, so we're expecting only numbers, et cetera, et cetera. If we cannot do input validation, for example, like a blog post, right? We don't want to limit the users to use only certain characters. We say, yeah, you can use whatever, less than, greater than, semicolon, all the special characters, sure. So we're going to do output encoding on the server side, where we say, yep, this output is going into the browser, so we're going to use specific context. Yep, it's going to be HTML. We're going to encode it with HTML encoding so that the browser, when the browser displays those special characters, the browser doesn't execute them as a command, right? Browser just says, okay, this is a less than angle bracket, right? So going to show that angle bracket. I'm not going to interpret it as part of JavaScript. So that's all good. And for years and years and years, we were saying that input validation, output encoding has to happen on the server side because you control the server. You don't control the browser. Any validation that you have in the browser can be disabled by the user. Finally, we kind of figured that out. Well, now we have that DOM-based cross-site scripting that is completely in the browser. So everything we do on the server is not going to help us. Because in most of the cases, the input doesn't even travel to the server. It just stays in the browser. So you can have all your validation, input validation, output encoding, and there's still going to be a problem. So what do we do? Well, one way is to do same things, input validation, output encoding, but on the client side as well, when you know that you have that logic in the front page. Tedious. Right? And I mean, even with the server-side validation, we've been doing that for years and years and years. XSS was first part of OWASP Top 10 in 2003. It is still in the top 5 in 2015. So we weren't very successful in fixing it, obviously. How are we going to be successful in fixing another type? Yeah, there's always a way. You close one thing, you close another thing, but there's still a way to bypass that input validation, right? So let's look at some examples of how that happens. Anybody writes JavaScript, reads JavaScript? Yeah? All right. All right, some JavaScript samples with some Java code. So for example, one type of an injection where we have an inline JavaScript, right? So this is our JSP page. We get a parameter from the request, right? Get parameter s, some parameter from the URL string. And then when we write the response in the HTML page, we reflect it right away. We reflect the search word right away. And it's usually, you search for something and the next page says, here are the results you searched for this, right? So we are expecting a search word. What we're getting is something like that, yeah? Script, alert, XSS script. So that's obviously just a simple sample JavaScript. It's not malicious or anything, just gonna pop up an alert box. But because there's no validation, that script alert script becomes part of the page, and when the browser interprets that, says, okay, this is a tag P, which means this is a paragraph. This is a tag script, which means everything after the script I have to execute. So that's one type of injection. That's called an inline JavaScript injection, right? We inject the JavaScript into the HTML page. So another type can be when we say, okay, maybe the search word has a limitation of how many characters you can Right. That's legit. It says, okay, 100 characters. So maybe 100 characters is not enough for us to write a long malicious JavaScript that will actually go and steal your session data or forward you to a malicious page and ask you for username and password or something like that. So another approach is to inject a link to a script that is loaded from somewhere else. Right. So same stuff on the server side, but instead of injecting script alert script, we are injecting script, and then we're specifying the source that this file will be loaded from attacker.com. It will be loaded, it will become part of the page and will be executed. And that's one thing about the way the browsers work. So they have a protection system that's called same origin policy, where scripts from one origin, and origin is your domain name with a port, with a type of connection, HTTP, HTTPS. One domain cannot read the data of another domain. Like when you open your Gmail and you have some ads on the side, can the ads read the contents of your emails? We hope not, right? So yes, because the ads are loaded from another domain, the same origin policy protects them from just going and reading the contents of your emails. However, the script is an exception. You can specify, for example, this page is loaded from example.com, but you can specify whatever website, whatever domain, and load whatever JavaScript you want. It will become part of the page and will have access to everything on the page. So that's the second type of how we can exploit that injection, right? The third type is an injection inside our JavaScript. So JavaScript has this wonderful, wonderful function that's called eval, that whatever string, text string you pass into, it's going to execute it as JavaScript code. Makes the language very, very flexible. However, it's a great tool for the attackers, because whatever attacker sends into eval, that's just a code execution, right? And it's just going to run it. So in this case, suppose we already have that code snippet in the application where we are reading something from an element called parameter, and we want to evaluate a function that we have and pass that, whatever we got from the parameter, our user input, as a parameter to that function. So a malicious user, instead of sending their first name, what we're expecting, are sending something like this. Again, in this case, we're just saying, oh, we're just going to send an alert XSS, but the point is that we can inject any JavaScript we want instead of the first name. So that is the DOM-based cross-site scripting. It's all happening in the browser. There's no request to the server side, and obviously no response. So there are different ways, and as I said, we were trying to fix it for many, many, many years. Didn't work, so we came out with a new solution, right? The browser group came out with a new solution called Content Security Policy, where it says, well, let's tell the browser where we are loading all the resources from, including the script. And we say, we don't trust any scripts that are loaded from attacker.com. We only trust scripts that are loaded from us and from a few of our partners. So that's one thing. And if we look at this page, right, if we think about the attack surface for this page, what are the different ways an attacker can exploit the page? There is a form, submit form, right? We can inject malicious data there. There is some inline JavaScript. If it has a vulnerability like DOM XSS, we can inject there. There are some scripts that we are already loading from third-party domains. So if those domains are untrusted, if those domains were compromised, now we can load some malicious script into our page. There is a third-party plugin, say Flash. There is an iframe. All of these things can be used to make an injection. And content security policy specifies certain directives saying, okay, you can only load scripts from this location. The connect source will tell you you can only connect using a web service, WebSocket call to these websites, to these specific domains. You can only use fonts from this location, iframes, styles for CSS, images, media, etc., right? Object for Flash and Silverlight and applets and plugins. And the most important thing, say, we're going to disable any inline script. Because if we go back, the only reason why, like one of the reasons why, so basically, as I said, we say we're only allowing script from certain locations, right? So that's not going to work. Because, okay, attacker.com is not in our whitelist. And also they say we're not going to allow any script that's inline. We'll stop executing any inline scripts. And because eval is evil, we're going to stop using eval. So all of these things are disabled by default as soon as you start using CSP. So the way it is configured is that you set the policy on the server side as an HTTP header, and then the browser that the client is using has to support it. And today, all the major browsers are already supporting it, so that's good news. So for example, we are setting a policy that says, okay, we can also set up the default directive. So by default, all the sources can be loaded from self, so from my website, which is example.com, and from mydomain.com, and all images can be loaded from star. So can this page load an image from bbc.com? Yes, right, I said star. What about this one? With this policy, can a page load a script from attacker.com? So there is no script source, right? We're not specifying it. But there is a default. So since there is no script, the default will work, and default says from myself or from star.mydomain.com, right? It does not list attacker.com. So that policy will stop any script that's trying to be loaded from attacker.com. And the next one, can the policy load a CSS file from WordPress? Why do you think yes? That's the correct answer. Right, so there is no style tag that doesn't say to us anything about CSS. And by default, the default is also not specified, right? And by default is open. Like by default, you can load anything from anywhere. Since we didn't specify anything here, yep, you can load everything. So that will work. Yeah. Another cool thing that CSP provides is that if there is a violation of your policy, if something is still trying to be loaded from somewhere that you don't specify, you can configure a reporting mechanism. You configure a parser on your server, and basically each time the policy is violated, each browser, each client, whenever they load the version of your website, will send you a violation report in this JSON format, right? Or some version of this JSON format, I should say. So they will say, this policy was violated, this is the URL that was blocked, and so you can see exactly where the attack was coming from. Like this is a very, very powerful tool just to monitor, just to see what attackers are trying to inject into your websites. And in most cases, it's not going to be just the attackers. It's going to be your normal functionality of the website, because developers forgot to mention this script or this URL for the font or this URL for the image. So which helps you to basically debug and find all these missing things. There are going to be some information from the plugins that a user has in the browser, because the plugins will also try to inject something. So it's valuable information. There's one caveat that the browsers, unfortunately, are interpreting this very simple format, slightly differently. So the names of the attributes are slightly different. Some browsers add extra attributes, but it's still manageable. So you can collect all this data and graph it, use it for development, for debugging, etc. So that's great. Even better, what if, when you configure the policy and you enable it and there are a few URLs that you forgot to put in, everything's going to break, right? What if you don't want to do that? Well, you can configure the report only policy that's not going to enforce the policy. It's going to just check if there is a violation, it's going to send you a report, but your website will work, especially at the beginning stages as you're developing that you're just starting to use CSP. That's a great tool, the report only. And moreover, you can have both headers. You can have content security policy and content security policy report only on the same website. So you're going to use a more open policy at the beginning, say, well, allow everything or almost everything, and how about we start with this more restrictive policy and then collect the data. Is everything still working? How many violations we have? All right, we fixed all the problems with the violations. Now we can push it into the actual CSP policy. And as I said, we need to remove all the inline JavaScript from our normal code. Is this easy? Well, this is our kind of traditional, the way we traditionally wrote JavaScript or HTML, right? We have some page, we have some script inside, we have some functions, we have some like a button, we have some event handlers, onload, onclick. So now we need to get rid of everything. We create a separate JavaScript file, we move our functions there. Notice that we have a function click handler set timeout, which has some code in the double quotes. So set timeout is actually one of the eval constructs functions. So it's using eval behind the scenes. It's going to evaluate that console.log, logging something, and then calling the function repeated after the time has come, right? When the timer clicked. So that's not going to work anymore. So now we need to take this function, put it apart, make it into a separate function because we cannot use eval or eval constructs. So we created a separate function that's called repeated task, pulled out those tasks there, those calls. And what's more complex is that now we cannot use any event handlers. That's not very helpful. Like it's really unlucky. So instead of using event handlers, what we can do is we create a document and we create events and we put an event listener and we say, add event when DOM content loaded. That's basically our onload function previously. Do call our init function, initialization, and also find that button and add an on-click event to the button. So add another listener. So then our HTML will look like that. Kind of like in 1995, before we used all the extensive JavaScript, right? Just the static content and like one call to a JavaScript function. So that's actually very, very tedious, especially if you have an existing application with a bunch of event handlers, and yeah, it's like starting from scratch. So that is one of the reasons why the adoption rates were not as high at the beginning. Right now, all the major browsers are supporting it, except Internet Explorer, although they say the Edge browser supports it. I haven't tested it, but that's what they claim. They say, yep, we're gonna support it completely. So almost everything supports it, except for things like Opera Mini. I don't know if you're using Opera on your mobile devices. If we look at the data from 2013, right, how many websites were using CSP headers? Well, out of 1 million top websites, only like 269 used it. a little bit more with other types of the headers, because also just 2013, not all the browsers supported the CSP header as is. Some of them supported, like IE, and still supports the XCSP header. The WebKit browsers had their own header prefix with XWebKit, but more or less 200 something out of 1 million browsers. That's really, really slow, really small percentage. The other interesting thing is that CSP has 2 more directives. Well, suppose you decided to use CSP, but you're using a library that is using eval function. And you have to use this library, say it's jQuery or something like that. And you don't have the resources to rewrite it. So you're like, well, either my website doesn't work or I have to allow eval. So what you do is you say, I'm going to use that directory that says unsafe eval. Now all your set timeout functions, set interval functions, eval functions are going to work. But I love how they called that directive. They're saying, well, yes, you're allowed eval, but now you're unsafe. You have to realize that. And same thing with the inline script. If you want to allow inline script because you cannot rewrite the whole application, you say, yep, let's allow unsafe inline. And if we look at the data more closely, out of those 269 websites, 257 were using these 2 directives, which basically made their website as vulnerable as they were before using CSP. It's like, what's the use of using the technology then? So, yeah, that didn't work really. However, there are some companies that were able to use CSP1 full-blown, and one of these companies was Twitter. So they were very loud about it, and they were like, yep, we're implementing CSP. They started with some small applications that they have, like the mobile version of Twitter, some other helper applications, and then they finally said, yep, the Twitter also uses CSP completely. So I decided to look at the headers. And the first CSP header that I see says script source, unsafe inline on unsafe eval. I'm like, really? Twitter? After all this buzz that you did, and like that's as far as you could go? So then I looked further as the site was still loading, and they overrode that first header. I don't know why they still have it there, but they loaded another one. And this is a beautiful piece of work because it says script source, and that's it, right? It has 2 other URLs, abs@twittimg.com, abs@0twittimg.com, but that's it. No unsafe eval, no unsafe inline. So they were able to do it. Thumbs up for Twitter. And notice they're also using the reporting mechanism. The last directive here is report URI, and they're capturing all the reports. The next company who was also loud about it was Yelp. However, if we look at their headers, unsafe inline and unsafe eval is there. That's as far as they could go, which means, yeah. I mean, they're using it to control the content, but they're not not using it to protect themselves from XSS. And the other interesting thing that I found in this policy was the first directive, the default source star. Like, that's what it is by default. Why do you even need to specify it? I don't know. Yep. So CSP1, not widely adopted. It's really hard for existing projects. It's doable for new projects. If you say, all right, we're going to start from scratch, and we're going to use it, and this is how we're going to write JavaScript, and then you can use it. But people realize that, yep, the first version doesn't really apply. So the suggestions to the second one include different ways to still keep the inline JavaScript so that you don't need to rewrite the whole application, but make it trusted. Somehow sign it and say, all right, I trust this piece of JavaScript. It comes from my server. You can execute it. Whatever else is injected, don't try to execute it. And those things are nonce source and hash source. Some other changes that they're adding is like you can now specify the policy in the meta tags instead of the HTTP headers. I don't know what's kind of the use case or value. The CSP is still a candidate recommendation as of July of this year, so it's still being developed. It is partially supported by some browsers because since it's still being developed, we don't know what the final standard is. But the latest versions of Chrome and Firefox support a lot of functionality from CSP too. So what are these headers? The nonce, we in software security, we like nonces, we like tokens. We say, this is the token, I gave it to you. If you show me this token later, I know that I gave it to you, I can trust you, right? So that's the same idea. We're going to prepend each JavaScript, just put another attribute and say, okay, this is the token that comes from the server. And also add that token into the HTTP header. So when the browser is executing the JavaScript, rendering the page, says, okay, I have this JavaScript. Let's see, should I be allowed to execute it or not? Well, it has this token. Let's see if the token matches to what is sent as the HTTP header. Right? If it does, the browser runs it. If it doesn't, the browser just ignores the JavaScript or sends a violation request if you configured the report policy. So that's good. However, from the developer perspective, the question is when and how do I add these nonces? The nonces have to be different for each time you reload the page. They have to be unpredictable. You have to store them on the service. Well, no, you don't need to store them on the server side. So that's a good thing because you just have two copies, one on the JavaScript, one on the HTTP header. The good thought, the easy kind of approach is that, okay, I'm going to interpret my page, I'm going to do all my business logic, and as soon as I'm ready to send the page off to the user, I'm just going to go through all those JavaScripts and stick a nonce to each of them. Well, the problem is, if we think back about the reflected XSS, where an attacker sends you a piece of JavaScript and it's injected into the response, and then afterwards you're attaching all those nonces, well, the response is going to be there already. And now you're signing off on the piece of JavaScript that came from an attacker, from somewhere else. So the approach works if developers use it correctly. But there is a way to use, an easy way to implement it, and you leave the application vulnerable still. So then there is another approach. The approach of the nonce directive. Oh, another question. If we have that JavaScript and we signed off and you say, yep, we trusted that JavaScript, but the script itself has a vulnerability, like we saw in the DOM-based, will it fix the issue? No, right? The script already has the vulnerability. Somebody injects into that script, writes extra JavaScript in the same script block, and since you authorize everything that comes between the script and script, and you don't know if that has been modified at some point, the vulnerability is still there. So when we need that integrity, when we need to say, I'm sending you these 15 lines of code, and when you're executing them and the microphone died. Yeah. I think the room is small enough, but the video will probably not get.
Well, we have sound recorded from close to your camera cameras.
Okay. Yeah, it's better. One speaker, 2 days. All right. So when we want to ensure that whatever page, whatever content we're sending to the browser hasn't been changed, hasn't been tampered with, what do we do in security? Sign the con, right? Like hashes. That's another thing we all usually do. So another directive is a hash, right? We take whatever is in between the script tags and do a hash and specify, yep, that's SHA-256 or whatever, and send that hash in the HTTP header. So again, the browser absorbs the page, that there is the content security policy and it specifies script source SHA-256 and here's one hash, here's another hash, etc., etc. Sees those hashes and says, all right, I guess I need to hash every chunk of script and validate if the hash matches. So takes the hash of the script, if hash matches to one of the ones that you're sending here, the JavaScript is executed. If somebody modified the page on the way, if there is a down-based injection, the hash is not going to match, so the script will move on. So that's great. Again, you have to generate the hashes. That's an extra step. You have to use some kind of library that does it, or write your own library. You have to add them on each step. It's extra work, but it's for sure protects your page from any injected JavaScript. But still we go to the question like, well, how do we write our pages so that it contains the minimum amount of JavaScript, right? And today we are super lucky because there are already a bunch of frameworks that do that for you. All the data binding frameworks that allow you to write your HTML page without any JavaScript, right? You just specify the binding of, okay, this is the username that is displayed, this is the search term that we asked for that is displayed here. We're going to bind it to a certain variable in our model on the client side, and the model is in separate JavaScript file, right? It's not together with HTML. We separated our view and our data. So if you're using one of these frameworks, most of them are JavaScript except Django, of course, then you don't need to worry about it, right? Basically, all these frameworks are supporting CSP out of the box. You configure them, you configure where you're reading your JavaScript from. The mic died.
Oh, it died.
So,
okay.
yeah. So that's good news. If you're starting a new application, you want to use CSP, use one of these frameworks, you're going to be in good shape. Somebody took it to batteries, but yeah, but now I don't have my So that's pretty much it. I have a list of really good resources about content security policy. The slides I'm sure are going to be on the website if you want to take a picture or read later. So open to questions. I know I finished earlier, but yeah, we have a few minutes for questions.
It's more of a musing, but I'm kind of wondering, this is something that the website owner itself has to do, right, on their website?
That's what the developer of the website has to make.
So I'm kind of wondering if this could possibly be extended to, it would have to be sort of a whitelist sort of deal, but extended to a client-side browser. Say you want to apply something like it might end up breaking things, which is why you have to test it a lot, but if you want to be safe and make sure that you're not downloading anything that's from any other website that you want to visit, use a local CSP website has provided one.
So there are plugins for that. There is one plugin. Let's see if I have. So Stuart Larson, who also gave a talk in AtlSecCon, California. He has a plugin called Casper. So it's a Chrome plugin where you can write your own CSP and just for that specific reason to test, right? What if I apply the CSP to this page and let's see how it works. You can also set up the reporting mechanism and get the reports and kind of play with it. But in general, it works for testing, playing, researching purposes. But if you want to set that up for like CNN.com, you have no idea how many resources they are loading from all over the place. So you're going to set it up, and suddenly all the images and videos are not loaded, right? So yeah, so it's a great tool to play around, but developers have to take that effort and responsibility to configure the CSP. You don't want to trust the users what they configure, right? So, any other questions? What do you mean by automatically validate? Oh, to try to, like, from the attacker's perspective? So, the question was, are there any tools to automatically validate the policy, basically try to find the vulnerable places in the policy, right? What else can we inject? No, I have not seen the tools for that. But I'm sure, like, with a plugin, it will be easier because you can test. But yeah, no, there are no plugins there. It would be great if, like, Burp or somebody like that invented that. Yeah, it's not a bad idea. Any other questions? All right. Thank you, everybody.